Okay. Hello, everyone. Welcome to CASI Web Talks. My name is Danielle Tremblay. I'm the communication specialist at CASI and the producer of the webinar series. Our usual host, Jeff Longaduck, our executive director, is ill today, so I will be your substitute moderator. As you know, our guest is Jerzy Komorowski. Jerzy has been the general manager of the National Research Council's Aerospace portfolio since January 2012. He assumed this role, having moved through positions of increasing responsibility with the organization that was previously known as the Institute for Aerospace Research. Before that, the National Aeronautical Establishment, as it was called, in 1982, 35 years ago, when Jerzy came on board. During his career, he has published more than 100 reports, journal, and conference papers. His early research was focused on experimental strain analysis, as well as environmental effects in composite and metallic materials. In the 1990s, he was active in the field of non-destructive inspection, developing new optical inspection methods and pioneering models of the impact of corrosion on the integrity of aircraft structures. As director of the Structures, Materials, and Propulsion Laboratory, Jerzy helped it to become one of the leading research centers for holistic structural integrity design. His presentation today is entitled Reflections on 12 Years as the Manager of NRC Aerospace. The PowerPoint file is located in the handout section on the control panel. Please feel free to download it after the presentation. You may use the chat tool to submit questions and comments during the presentation, and we will have a Q&A afterwards. So I'm just going to switch over to Jerzy now and hand the floor to him. Please welcome Jerzy Komorowski.
Hello, everybody. Thanks for taking time off your busy schedules to listen to the rumblings of a guy that's about to retire. This is my last month at NRC, and it's been a wonderful run. I am extremely happy with my long time with NRC, and I thought that it'd be interesting to share with you, with CASI members, exactly what were some of the major accomplishments during the last 12 years were from being DG of IAR, the Institute for Aerospace Research, I moved to being a general manager of the NRC Aerospace portfolio, to finally, as of 1st of October this year, to be again a DG of what is now known as NRC Aerospace Research Center. We've been pretty stable organization through these years. So my talk is a little bit about NRC renewal. This is why am I again Director General, and why NRC Aerospace is now known as a research center. And then I'll talk a bit about NRC Aerospace itself, and finally move on to more specific issues related to how we achieved these some of these accomplishments. I'll talk about the role in aerospace innovation, our competition and external engagements, our other government department engagement, and finally some new directions that we are taking. And at the end, I will answer your questions. So just to remind some of you about NRC, we have a national presence. If you look at the map, the squares are our research facilities, and the little triangles are the IRAP offices, the Industrial Research Assistance Program, which is the only part of NRC that actually grants support funding to R&D efforts of small and medium enterprises. We have about 3,700 scientists, engineers, technicians, other specialists, so 178 buildings, and about a $1 billion annual expenditure. Current organizational structure, so we, as you can see, the president, we have a new office of Chief Science Advisor and a new committee that the president is standing up, which will be his advisory committee made up of the senior researchers. As you go down to the third layer, you can see our divisions, and there are 4 divisions now, and the Industrial Research Assistance Program, and Aerospace is part of the Transportation and Manufacturing, a newly created division which was split off from the Engineering division. Just moving more onto NRC Aerospace, we operate an astounding wealth of facilities that moderately and very conservatively estimating would take at least $500 million to replace. And you know of our wind tunnels and aircraft. We have 9 aircraft. We have structures and materials in manufacturing facilities and gas turbine facilities. The NRC Aerospace is present in 3 different locations in Canada, primary in Ottawa, near the airport and on Montreal Road. Also in Montreal, where I am physically right now, on the campus of Université de Montréal, and we have some facilities in Mirabel, north of Montreal, as well as in Thompson, Manitoba, and I will talk about those a little bit more. The 350 people that make up our research center are specialists in aerodynamics, in manufacturing, in flight research, structures and materials, and gas turbines. And I find that one of the important abilities that or competences that we have is technical services. We work very closely with industry, and that required a certain discipline in delivery. And we have very formal ISO quality system in place, project management, discipline. We needed to introduce security for obvious reasons, and export controls. We needed ability to work with controlled goods and ITARs. The delivery right now of our efforts is primarily through 5 programs focusing on Air Force, on defense, on icing, all issues of icing in aviation, unmanned aircraft. We're focusing on people on board aircraft, both as the crews and passengers. That's a new direction that we've taken. And of course, we support our industry in their efforts to develop and at times certify their products. How we create value is through these 5 programs, which is the circle. Inside you see that really we have focused on strategic collaborations and roughly produce about 700 joint publications. We work internationally with other government departments, with academia, and of course the industry. All these connections are quite important to us. As far as the role we play in Canada, it is sort of in between the university academic research and industrial research, and it's a bit of a unique role, which comes from the combination of facilities and people which we have. You know, half of our staff are researchers and half are technicians. You wouldn't find that kind of a mix either in university or in industry. We plan projects, and you know very well of organizations like CREAC and Garden and CARIC, but they are primarily focused on defining projects and funding them. We do that too, but we also have the ability to deliver on the work, as do universities and industry, of course. We also have been very instrumental in the sort of helping the sector to develop strategies, and in that sense, roadmaps were quite instrumental. And one of the most recent roadmaps we have developed with industry, what we instigated that, was the Canadian Aerospace Environmental Technology Roadmap. It was a true collaboration between all important players in the Canadian innovation system, and it's a declaration of the intent of the industry to be more green. I have to say, personally, I'm very proud to have instigated this, and there is a serious consideration to update this roadmap, which was first prepared in 2009 and then updated in 2011, and there is a consensus growing that we need to update this. But sort of the direction into environmentally responsible aviation has produced an amazing event or research, I would say. It wasn't just an event. We were first at NRC to operate a jet aircraft on 100% biofuel, biojet. There was an interesting happy meeting of NRC Institute of Plant Biology, who produced this amazing plant, who are growing this plant. It's called carinata, that is very rich in oil, and the oil derived from that plant, we were able, with an outfit in the United States, to convert it straight to a drop-in fuel. As you know, most flights today are on a mix on blended fuels. They're quite common. Even Air Canada now operates flights between Toronto and Montreal on a blended fuel. We did not only, flew our Falcon with this 100% biojet, but our T-33 was able to measure emissions, and we noticed smaller reduction of emissions, but we really saw very big reduction, more than 50% reduction in particulates. It was very interesting, and this flight was probably the most attracted incredible attention from the media. Now, it's important to note, and that when we became members of the International Forum for Aviation Research about 9 years ago, it's a new organization that members of that organization are our peers in countries that have aeronautics ambitions, and now there are 26 countries members of that organization. And when you consider that there are these organizations like NASA, JAXA, DLR, and others employ 35,000 people with a combined budget of $5 billion a year. NRC Aerospace employs 350 people with a budget of about $60 million. That's everything that we can bring in, plus the NRC allocation, and this is our competition. And so the only thing you can do in a situation like that is truly engage and leverage these sources by collaborations. And in that sense, I have some personal pride in the fact that I have initiated and helped to create the Canada process, which led to a special joint call between Canada and European Commission. And there are first projects which are managed by CARIC. We have signed an agreement, a collaborative agreement with NASA, who are notoriously difficult in terms of international collaborations, but they recognize our expertise and focused on that, and we have been working with them for quite some time in all aspects of icing. We're working with JAXA, the Japanese Exploration Agency, on aircraft safety. We have more recently signed an MOU with DLR and are looking at growing those collaborations. We have a number of MOUs and framework agreements with the Canadian and multinational OEMs. And finally, I mentioned EFAR, and just to give you a sample of what can be achieved through these collaborations, a couple of years ago, NASA invited DLR and NRC to collaborate on measuring emissions in contrails from their DC-8, which was flying a blended fuel, 50-50 blended fuel. We contributed our T-33 to this effort, and this year a paper in Nature journal was published, and that paper was chosen by NASA Science Directorate as their best paper, and our pilot Anthony Brown is co-author on that paper. So that's quite a major achievement. Engineers very rarely publish in Nature. Another outcome of those big collaborations and engagements is the facility we established in Thompson, Manitoba. A great place, 256 days below freezing in northern Manitoba. This is the Global Aerospace Center for Icing and Environmental Research, where we can, where the biggest gas turbine engines are being certified in icing conditions. This is a partnership between Pratt & Whitney Canada and Rolls-Royce, and it was designed, built, and operated by MDS Aero, an Ottawa SME, whom we have invited to play that role. Essentially, we were approached by the industry because of our reputation in engine icing to establish this facility, we are involved there. And more recently, the geared turbofan, the Pratt's now famous engine that's on the Neo and the C series, has been certified there, and the newest engine of Rolls-Royce, which is on the Airbus 350, has been certified there. And it's a facility that's quite popular, of course, with the Pratt and Rolls-Royce. Another achievement that I would like to mention is in technology transfer. We, working with Bombardier, have designed and delivered to them a robotic test cell, which was installed in Saint-Laurent, and it is an interesting project where you have two collaborating robots, and the challenge here was that the human operators who were doing this job before the robots were maybe after 3-4 months at most, usually were on sick leave because of the very unfavorable position in which they had to work. So we improved the quality, but also removed the negative health impact of this assembly task here, which involved one of the Bombardier aircraft. Another example of technology transfer was some collaborations with IRAP, which we did, where we essentially delivered a first friction stir welding automated cell to Sedul-Tremblay. This is not an aerospace application, but we have completely automated the process of repairing electrodes, the big aluminum electrodes they use, and they produce in thousands, and that way are saving a lot of material and tremendously improve the productivity of this company. Another examples of external engagements are, of course, our engagements with other government departments, primarily Canadian, but not only. We have a long-standing agreement with D&D, where we have an MOU which allows us to easily enter into collaborations, and while successes were many, the couple that, or three that I want to mention is the work we did on the ship helicopter operational limits. It's quite challenging to land helicopters on ships, on frigates, and we have continued to work with our Navy and Air Force to enable to safe operations of helicopters in that environment. Another one that we're quite proud of is that we were asked to comment on the procurement of the fixed-wing search and rescue fleet by the Department of National Defense. That was back 5 years ago, and it was a tricky situation because we were asked to do this by Public Works, where the project was not going forward because of arguments between Industry Canada and Department of National Defense, both extremely important departments to NRC. So being in the middle of that conflict was quite uncomfortable. Nonetheless, we were able to study the requirements and produce a report criticizing the statement of a requirement that was prepared by D&D, which helped them tremendously move forward. And an anecdote that I can share with you is that we delivered the report within 6 weeks from getting a contract from Public Works. A year later, Rona Ambrose, who was the Minister for Public Works at the time, was in NRC booth at the air show, and she said, "Okay, nice NRC, nice, but why did it take you a year to produce this report?" So I had to tell her that not only it took us only 6 weeks, but it took 2 months for her Public Works officials to issue the contract, which was a one-page contract. She had no clue. I guess it took a year for the report to reach her office after we issued it. Anyway, the big thing, the big outcome is that the 16 C-295Ws were procured in 2016, so the procurement of a fixed-wing SAR fleet is finally moving forward. We are working with Transport Canada and the European Aircraft Safety Agency on de-icing fluids. We do microgravity flights, so we do some space work, related work, offering the Falcon to the CSA and whoever else needs it. We operate reverberating chamber, where we test space hardware before it's launched, and the big thing was testing the Aerospace 2, but we'll test anything else that we will be required to do. And finally, we did some fun work in our high-speed wind tunnel on Mars lander parachutes. So I never expected that we would be testing parachutes in high-speed wind tunnel. That was quite interesting work as well. Coming back to a D&D project that was such a success, that was the radar and imaging for land littoral environments. Essentially, our Convair became the most advanced ISR platform for a short duration, just to demonstrate what's possible. And this technology demonstration enabled D&D to procure new suite of sensors, which they will use for Aurora aircraft. That was a fun work. Another fairly important work we did was the composites technology demonstrator. We have worked with Bombardier Bell Helicopter and Composites Atlantic as a first demonstration of automated fiber placement in Canada, and you have the machine at the lower right corner, the picture of the automated fiber replacement machine, which was procured for that demonstration, and we have with the partners built the forward part of the fuselage and a table. And what was really important is that first for Bombardier, this opened this fiber replacement technology for them to choose it for the C series, and for the Industry Canada, or now known as ISED, this demonstrated what a technology demonstration is, and now it's a 55 million a year program to be matched by industry. We have worked very hard to explain to the government the need for technology demonstration program in Canada. So this was very instrumental in achieving that result. And finally, to end this lengthy discussion or the presentation that I wanted to share with you is our newest addition. We're just about putting last touches on a new $10 million facility, cabin comfort environmental research. It's next to our hangar, so for those of you who live in Ottawa or come to Ottawa via the airport, you will notice next to our hangar a new building, and it's a place where we will be researching environments that passengers and crews experience on board aircraft, and first time try to put some science into how on what conditions we create for people on board aircraft. So that we've hired quite a few physiologists. It's a very new direction to us, and already we have significant interest from the industry. One has to remember that aircraft interiors are replaced at a much higher rate than aircraft themselves. So typical airline will replace the interior every 5-6 years, and how they do it is fairly arbitrary. What we would like to do is bring much more discipline. One of the examples we have is to develop sort of a comfort index where it will be not a subjective but really objective measure of how good the interiors are. So I'd like to leave you with this thought, which I like to bring back, and that's that it's not the strongest and the most intelligent, but the most responsive to change. And with that, I'll bring you to the size of our competition. And while we're small, I hope that we will remain agile and able to compete even with the strongest. So that's all, and I will be very happy to answer any questions that you may have.
Thank you very much, Jerzy, for your presentation. We do have some audience questions that we would like to get to. We do have a few minutes to go through those, so we have a few already in. If there are others who would like to send in a question, we'd be happy to ask Jerzy on your behalf. The first question is from Karina Sapelnikova, and she's wondering about career opportunities for Bachelor of Science Engineering students in NRC Aerospace. She asks, do you recommend recent graduates complete a Master of Science before applying to the aerospace industry?
I definitely recommend getting at least a master's. If you are thinking of working for NRC, we do have engineers with bachelors. They typically play supportive roles. The research is mostly managed and sort of led by people with both masters and PhDs. So I have a master's. I don't have a PhD. I just had too much fun, I guess, after joining university to devote myself to get going back to academia. But I have some regret about that. So for young people, really get a higher degree, because it will open many opportunities for you. That would be what I would say. With that, though, you know, the supporting roles are extremely important for us operating the complex facilities that I mentioned, you know, very briefly. We do need engineers, good engineers as well.
Okay, very good. The next question is, how is the NRC Aerospace involved in the rapidly emerging area of unmanned systems development and applications?
So we have a program. I quickly glanced through that. We have a program which is focused. We originally focused on applications of UAVs in the civil sector. And while we were doing this, we were working on the autonomy, on giving UAVs ability to be operated beyond line of sight, because it is clear that major applications to things like pipeline monitoring, hydroline monitoring, you know, looking for fires, all those applications that will really be opened up once we can operate UAVs out of line of sight. The other aspect, which also we are now focusing on, is that while today there seems to be this dichotomy between piloted and unpiloted aircraft, we believe that the future is merging of the two, and there is already projected significant shortage of pilots. So the minimum will be taking one pilot out of the cockpit, which implies that you have to have a backup system that would allow you to at least safely bring down the aircraft should that one pilot become incapacitated. So we really think that that's where the future is. It's true, there are many smaller companies that are working on certain aspects of the civil UAS, and we are working with them on this.
Great. Another kind of crystal ball question. What near-term innovations in aerospace do you consider to be the most promising and that will have the greatest game-changing impact?
Well, I think it's the hybrid power. It's the you know, increasing electric power, use of electric power on board aircraft, where it'll be probably through hybrid for somewhat larger aircraft. There are already 100% electric, smaller electric aircraft flying. I think that will be the biggest growth, biggest impact. I don't think that collectively the sector will be able to meet the carbon reduction targets for 2050 without major change in how it's powered. So while we don't have all the solutions yet, this is where I think clearly we'll be moving. Different configurations, you know, to move away from tube and wing will probably be after that. Okay,
great. I have a question from Glenn Priestley, who was one of our former CASI Web Talks speakers. He's with NADA. His question is, Northern Canada has challenges with providing accessible facilities, proper terminals, and then there's the permafrost degradation. Any NRC focused on northern issues?
Yes, we have been attempting to engage with potential airship, for example, programs. there are still a lot of challenges with airships and airship acceptance. I mean, you know, on a technical, purely technical ground, there are airships today. Airships have been known for 100 years, and yet we don't seem to be able to develop a sound business case to have airships operating on a commercial basis successfully. We are looking to that as a possible route to support the operations greater access to the north.
Very good, thank you. I have another question here from Reed Stevens. Does the NRC do any research into the cybersecurity of aircraft, including security of government-controlled communications such as data link, radio communications, GPS, etc., or any testing of specific avionics products?
So with 350 people within the NRC Aerospace, we do not have the capacity to take on this enormous field. Just to share with you, UTC Corporation, that's the corporation where Pratt & Whitney is part of, and Goodrich and a lot of the aerospace companies really are part of UTC, as are major building equipment builders like Carrier and Otis. Their research center is currently spending 40% of their R&D on cybersecurity. This is a huge, of course, effort. In NRC, we have ICT Research Center, and they do invest some of their effort. And there are other organizations within the government that are looking into cybersecurity. But it is a very worrisome trend, the frequent hacking and the potential of hacking of more and more digitized platforms is of concern.
Right, indeed. Just a quick follow-up question from Glenn Priestley. He's saying NRC ALMA is engaged with a NADA working group to test alternate runway surfaces, in this case aluminum. Any POVs on this initiative?
I have to say I don't know a lot about that. In terms of runway friction, a few years back we have been working again with NASA to determine, to measure runway friction in snow and icing conditions. So we have expertise to do that kind of work, but I'm not too familiar to comment on the specific project that you mentioned.
Okay. I have a question here from, where is it? There was one about the Mirabel. Here it is. Pierre-Olivier Langlois asks, what areas of aerospace research has the Mirabel facility supported in the past and supports currently?
So in Mirabel, we actually have equipment that is housed by Stelia. It used to be Composites Atlantic. So we have the big fiber placement machine, and we have an autoclave and some other equipment, which is accessible to industry when we do not require it for research purposes. So we are working with companies to improve both the equipment, to update the equipment, to keep it at the most advanced level. And so I would say that our fiber placement machine is probably, if not it's pretty close to the most advanced fiber placement machine there exists. And anybody in industry, and obviously just the proximity to other companies like Bombardier, Bell, and others in Mirabel is a great place for us to be.
Great. We're really picking your brain here today. I have a question that has come in from Jeff Longaduck, who can't be with us today due to his illness. His question is, actually he has a few, but I'm going to ask just one right now. What are some of the accomplishments of the People Research Program that explores issues related to aircraft cabin interiors? That's your new facility in Ottawa, right?
Mm-hmm. So while we were building the facility, work has been going on where we established some facilities in currently existing buildings. So now that the building is ready, we're going to move all that. But just to give you an example, we have been working to reduce the strain and the problems, health problems, for helicopter pilots. Often, particularly in the military, the helicopter pilots have fairly heavy gear on their heads, night vision goggles and things of that nature. And the extreme noise and vibration environment in a helicopter produces, negative health outcomes for their necks and backs. We were working with an SME to develop better damping seats, and so there are now, as a result of our work, there are new cushions for helicopters to reduce this negative health risk. So just one example.
Right. Very interesting. Okay. Switching gears, I have a question from Piotr Jasiobecki. He's asking about the NRC's role going forward with the GOC innovation agenda. What programs will you be involved in, and what will the NRC's role be?
So, well, the biggest, if you like, expression of the innovation agenda of the government is the announced competition for the superclusters, and it is the supercluster competition is in the second round. And NRC has provided numerous letters of support to the supercluster consortia that see themselves collaborating with NRC or needing NRC competence to move their superclusters and the projects around the superclusters forward. In our case, we have been very closely discussing with one of the supercluster, the MOST 21, which was put together by CARIC, where they are focusing on multimodal mobility. And while we focus on aerospace, for example, the cabin simulator facility is open to serve buses, transportation, land transportation, as well as sea transportation. And other colleagues of ours, we have other research centers that are focused on these other modes of transportation will be involved. So that's how we see ourselves. Our role is to enable technology development.
Right. Very good. I have a comment and a question from our Ottawa branch co-chair Jeff Bird. On behalf of the Ottawa branch of CASI, let me thank you and the NRC for your part in joint meetings to build the aerospace community. Any thoughts on building the people part of the aerospace capability?
Oh, Jeff is my old colleague from NRC, who I'm going to join on the other side of the retirement door. How to do that? I think we I think that we're already working on this, and there is an effort around the Aerospace Air and Space Museum with David Kitson, the DG there, to maybe create a sort of a cluster organization where we will provide a venue for different organizations to get together and kind of create something like a small version of Aerospace Montreal. I'm on the board of directors of Aerospace Aero Montreal, organization that has just passed its 10 years of its existence. And the growth of the organization and the importance that it plays in the community here in Montreal cannot be understated. We can do similar things at a smaller scale, and really look into the people aspects with its own multi-dimensions. You know, both in terms of the innovation, in terms of the change of the guard, in terms of drawing young people from very early, from primary schools and secondary schools, and present to them the vision of what kind of opportunities in future careers aerospace industry really has to offer. I think there are a lot of young people who have no clue about aerospace and not a clue about incredible aerospace sector we have in Canada.
Yes, exactly. Speaking of students, I have a question from a student who, his name is Zhang Jung Hong. He says, hello, I'm an international student studying mechanical engineering. If I want to find an aerospace job in Canada, are there any restrictions regarding my identity? And I'm assuming he means from his country of origin.
Well, if you came and saw the staff of NRC, it is very diverse. We have people, well, myself, I came to Canada as a 29-year-old person looking for employment. So, of course, you have to meet the requirements and get either a working visa or residence status in Canada in order to work in the sector. But based on diversity of people I meet throughout the sector, many of them were born and educated outside Canada. So we are still open to, you know, hiring good people wherever they come from.
Yes, exactly. Yeah. So I have another question here. This one is from Arnie Blarch. He asks about the NRC operates at least 6 wind tunnels of various sizes and applications. Which of these do you think offers the most unique capabilities?
Well, okay. The most unique, they're all in a way unique, and because of that, they are still open for business, and we attract clients from around the world. But if I were to single out one that's most unique, that doesn't have its parallel anywhere, would be our icing wind tunnel. It's not a big wind tunnel, but it's one that offers, it can generate icing conditions up to 50,000 feet altitude. So it has an altitude capability, and it has a capability to generate ice and snow conditions. So it is a unique facility where people come, for example, to test and certify probes, aircraft probes, and how significant that is. I will just remind you of this tragic accident where about 3 years ago, Airbus aircraft was flying from Rio de Janeiro to Paris, and at cruising altitude, it flew into ice crystal cloud. The pitot tubes were plugged. The pilots didn't know the speed. They lost the speed reading, and that generated a lot of confusion on board of that aircraft. And unfortunately, through a chain of events, but which started from the plugging of pitot tubes, the aircraft, with all the crew and passengers, crashed into the Atlantic. So, it's a facility that perhaps for a casual observer, it's not that impressive. It's not neither huge, nor shiny, but it does something that nobody else can do.
Mm-hmm. Yes, absolutely. I have another question submitted from Jeff. Is there any issue related to competition with the Canadian private sector in the areas in which NRC is active? Is it related to the technology readiness level of the research?
We always are very careful to avoid doing work that can be done by private sector, particularly, and typically we're because of significant overheads, a very large installed facility base, we cannot compete on price with a private sector organization. Because what we do does not make sense in if you like, in the wild. We do need subsidy from the government. So if you look at our budgets, about less than 50% comes from Treasury Board, and without that, we would not be able to operate, as a for-profit organization. Simply. So, so the things we do are the things that the industry needs. It's a special space, which I showed you, a sort of mid technology readiness level area, where typically, if you look globally, it's about 50-50 funding, government, industry. That's where we are, and that's what we take on. We do not displace private sector, and if there are examples of us doing it, I would like to know that. Usually, when companies see that we compete with them, they complain vehemently. But we also, when we see that certain service we provide is becoming very well established in industry, we simply stop doing it. Just a good example, we're right now getting rid of the work we were doing supporting flight data recorders. There are now companies that will do it gladly for airlines and in the civil sector, and we're just getting out of it. Even though it represents a nice revenue stream for us, we can focus our efforts on something else.
Mm-hmm. Yeah. So the last question, and it's kind of like an exit interview question, since you're going to be retiring. Engineering is essentially a process of problem solving. During your career at NRC, are there one or two problems you recall as being the most challenging, or with results that were the most satisfying?
Mm-hmm. Wow, there were quite a few. Perhaps I will mention one which is so personally close to me, because that's been something that in a research area I opened up myself, and which continues, where it's about structure integrity, and while if you look at the records there are very few aircraft accidents related to structure integrity, but that's only because we have been very diligent. We developed a very sound engineering approaches to aircraft structure integrity. But it's an unfinished business in a sense that the drive to better materials, better in the sense of more flexible in manufacturing, that offer us lighter structures, lighter solutions, new approaches to maintenance, inspection. It's a dynamic situation. So something that you think you solved 10 years ago, well, it's a problem that's coming back because we no longer use the alloys we used to use. Now we want to build everything out of composite materials. And we need to understand how these materials behave. So I was once giving an international presentation on structure integrity, and my subtitle was Unfinished Business. So it's rarely that you can say we solved it forever. I think we are constantly, I read every report that's every publication that comes, that's generated by our staff, and as I showed you, it's close to 700 a year. So it's a huge job of doing it, but it is amazing to know the breadth and the complexity of what the staff of NRC Aerospace is doing. It would be very hard to single out just this one problem we solved forever. I wouldn't want to do that.
Well, thank you very much, Jerzy. Thank you very much for your time today, and thank you everyone in our web audience for this really informative hour with Jerzy Komorowski. I encourage you to visit the NRC website. It offers ready access to information about many Canadian aerospace programs. And best wishes to you, Jerzy, on your imminent retirement from the NRC. We hope that you'll continue to attend CASI events and participate in the life of the Institute. You did promise me earlier you're going to get your member spotlight questionnaire back to me, and we'll have you up on our website in January. So on behalf of Jerzy and CASI and April Duffy and myself, Danielle Tremblay, and we wish Jeff a speedy recovery. And we'd like to thank you all for joining us on this last of our CASI Web Talk series program in 2017. And happy holidays, everyone. Happy New Year, and bye for now.
Bye-bye. Happy holidays. Thank you.
Thank you. Bye, everybody. Thank you, Jerzy.
Thank you.
I'm just gonna make sure everybody's out, because if we keep talking, people can still hear us.